Hey, hello and welcome to today's GFG problem of the day. Hope you're doing well. So let's see today's problem: intersection point in Y-shaped linked list. Okay. So what the problem is saying is we'll be given two linked lists and we want to return the point where two linked lists intersect. Okay. And if the lists don't intersect, then we want to return -1. Okay. So I'll make it very easy for you. Just one request to please subscribe to the channel, like the video, so that I get to serve more and more people. I get to help more and more people. Okay. So thank you so much. So here, let's see this example. Okay. So here is an example of two linked lists. So this is list one and this is list two. Okay. And we want to find out the intersection point. So what is intersection point here? It is 8. Okay. It is 8. Okay. Now, how can we solve this problem? So first of all, let's see the naive approach, right? So what we can do is we can have let's say uh, we can solve this problem using hash set. Okay, hash set. So what is an hash set? So the search and insertion time complexity, right? It is O of 1. So let's quickly see how we can. So what we'll do is, let's say we'll iterate. We will iterate through any list. For example, any list we can iterate, right? For example, either L1 or L2, either L1 or L2. So let's iterate this L1. Okay. So what we'll do is first we'll iterate through this L1 list. Okay, and we'll insert the nodes here. Okay, we'll insert the nodes. So when we say node, not the node data, but the node address we can say. Okay. So whatever is the address for this, right? Whatever is the address for this. Okay. Okay. So we are going to insert the address of the node and not the data, right? And not the integer data. Okay. So we'll iterate through this link through the node one by one and we'll insert in the hash set. Okay. So 8, right? And then comes this 4, right? 4 we ingested, and then this particular 5. Okay. So we ingested in the hash set. This is just a representation, a simple representation of hash set. It looks like stack, but it is not. Okay. Then what we'll do? So once we're done iterating through this list one and ingesting the nodes or the nodes addresses in the hash set, then we'll start iterating through this list. Okay. And we'll check with each node whether it is present, whether it is part of uh, this hash set or not. Okay. So here also we have 5, right? So this will not match to this 5 because the addresses, right, the memory addresses of these nodes are different, right? That is why they won't match. Okay. So since this node address is not part of this hash set, we are going to go to the next node. So we come across this node, right? And then we'll check again, is it part of this hash set? No, it is not. Then we'll go ahead to the next node. We'll check for this node. Is it part of hash set? No, it is not. Then we'll go to the next node. So when we'll come to this node, we are going to check, is it part of this hash set? Yes, the node address is part of the hash set, and hence we are going to return the data here. That is 8. Okay. So in this way, you're going to solve the problem. If there's no such node in the hash set, right, till the end of the linked list 2, then we are going to return -1. As simple as that. But here, what will be the time complexity? It is going to be O of m plus n. We are fine with the time complexity, but what will be the space complexity? It is going to be either O of m or O of n, right? So this will take extra space, like, right? So we can solve this problem at the cost of the space. But can we optimize this further? Okay, so let's see another example. Okay. Or let's say another approach. So what we're going to do is we're going to have two pointers. One will be P1, which will be pointing to the head of the linked list one, and one will be P2, which will be pointing to the head of the linked list two. So what we're going to do is we are going to, for example, let me also write the pseudo code. So we are going to iterate this. We are going to have a while loop which will iterate till P1 is not equal to P2. Okay, till P1 is not equal to P2. So let's see what we are going to do is, so P1 equal to if P1 is not null, right? If P1 is not null, then we are going to iterate to the next node. Okay, we are going to iterate to the next node. Or if P1 is null, then we will assign head 2. Okay, head 2 is what? Head 2 is this one. Head 2 is this one. Okay, this one. And head 1 is this one. So just be with me to understand what I'm trying to understand, what I'm trying to explain here. Okay, and what will be P2? If P2 is not null, then we will assign P2, we'll assign the next node of P2, right? Else, if it is null, then we are going to assign the head of the linked list 1. Okay, head of the linked list 1. So just be with me. I'll explain this. Okay. So here, for example, now we'll start with with the start of the with the node start, right? So P1 is pointing here at 4, P2 is pointing at 5. So here we are going to check here. Yes, P1 is not null. So we are going to assign the next node to P1. So P1 will point here now, right? And P2 will point here. Okay. Similarly, again, we are going to check here. Is P1 null? No, it is not null. So we are going to assign the next node to P1. So P1 will point here and we'll check for P2. Again, it is not null. So P2 will point here at 1, right? At 1. Okay. Then again, we'll check here. We also will at the same time we are going to check, right, if P1 is does P1 equal to P2? No, it does not. It is not equal to P2, right? P1 is not equal to P2. So again, we'll check here. Is P1 null? No, it is not null. So we'll assign the next node of P1. Okay, we'll assign the next node of linked list 1. Okay, so P1 is not now pointing here, right? Again, we'll check here. No, it is not null. So P2 will point here at node 8. Okay. Again, we'll check, is P1 equal to P2? No, it is not. So again, we'll check, is it P1 null? No, it is not null. So we'll assign the next node. P1 will point here. Okay. Again, for the same thing, P2 is not null. So P2 will point here, right? Again, we'll check here. Is P1 null? No, it is not null yet, right? So P1 will now point to null, right? P1 is now point to null. Okay. For P2, we'll check again. Is P2 pointing to null? No, it is not null. So we'll assign the next node. P2 is pointing to 5 now. P1 is pointing to null now. Okay. Now again we are going to check, is P1 equal to P2 in the while loop? No, it is not. Okay. Now we'll come to this statement. So P1, is P1 null? Is P1 not null? No, it is null. It is null. So in this case, during this time, we are going to assign head 2. So what is head 2? Head 2 is here. So our P1 will point here now. Our P1 will point here. Okay. Our P1 will point here. Okay, for P2, now P2 is pointing here. So we are going to check, is it null? No, it is not null. So P2 will point here. Okay, P2 will point here. Okay, okay. Now again, we are going to check in this while loop, right? Is P1 equal to P2? No, it is not yet. So what we are going to do here? So now we are going to check, is P1 null? No, it is not null. So we are going to assign the next node. So P1 is going to point here. Okay, P1 is going to point here. Okay, at this particular node. Now we are going to check for P2. P2 is null. So now we are going to assign head 1, okay, to P2. So P2 will point to at 4, right? So now let me again draw this linked list, right? Let me again draw this linked list. 1, 8, right? And then what else we have? 8, 4, or we can say like this, right? 4, 5, that's it. 4, 5, and this is a null, right? And second is what? Here we have 5, then 6, then 1, and then like this, right? Sorry. So this is our linked list, right? This is our linked list. And where is P1 now? P1 is pointing to here at node 6, and P2 is pointing at this node 4. Now, if you see now both the nodes, they have equal the length now. Okay. See, if you see, they are both at the same level now. Both at the same level. Okay. With this operation now, both are at the same level. Now let's go ahead. Now P1. Again, we are going to check here. Is P1 null? No, it is not null. So we are going to assign the next node to P1, right? Same for P2. We are going to assign the next node of uh, uh, P2, right? Now again, we are going to check, is P1 equal to P2? No, it is not, right? Just remember, we are comparing the addresses, right? No, they are not. Okay, so now we are going to go ahead. Is P1 null? No, it is not null. So we are going to increment, sorry. So we're going to increment P1, okay? Or we are going to assign the next node. Now P1 is pointing to 8, right? Similarly for P2, we're going to check here. P1 is P2 null? No, it is not null. So we are going to assign the next node to P2. Okay, so now if you see, both nodes are pointing at the same node, right? Both pointers are pointing at the same node. So here we are going to check, is P1, while P1 is not equal to P2, no, it will break now because both are same, right? And finally, we are going to return the data. So this is the intuition behind solving the problem. Okay, I hope you've got the intuition. Okay. Um, so let's go and code. So before going to the code, I'll request you to please subscribe to the channel, like the video. Okay. So first I'll show the Java code followed by C++. So head one, head two, and P2. Right. Now, as I have already explained this, let's write the code now. P2. Right. Okay. So what are we going to write? If P1 is not null, then assign P1 dot next. If it is null, then assign the head of other linked list, right? Similarly for P2, if P2 is not null, P2 dot next. If it is null, assign head one. Okay. So in this way, when both are null, right? When both are null at their same space, okay, at their respective space, then we are assigning. Then we are assigning the head of the other linked list. Okay. In that way, the length will be equal. Okay. So finally, what are we going to do here? If P1 is not null, right? That is, there is some intersection, then we are going to return P1 dot data. If it is not the case, there's no intersection, then we are going to return -1. Okay. So let me compile this. Also, let's submit. Also, I'll explain one more case wherein the linked list don't intersect. Okay, just be with me. Okay. So here, all the test cases are processed. Thanks for watching. Please subscribe to the channel. Okay, like the video. So here, let me quickly explain one quick example, right? So for example, for 5 and 6. So there's this linked list 1 and there's this linked list 2 wherein it is 1 and 2 only for simplicity purpose. So there's no intersection here, right? So P1 will be starting from here, P2 will be starting from here, right? So, with this logic, right? Whatever we explained, with this logic, whatever we explained, so it will it so when P1 is, so for example, right? When P1 is here, right? I won't explain all the steps, right? When P1 is pointing to null, P2 will be here. Okay. So next step, what we're going to do when P1 is null, so we are going to assign P1 here, right? We are going to assign P1 here. Okay. Okay. And then what we're going to do? Sorry, let me try to explain this again. So if there are two lists, right? For example, now P1 will point here and P2 will point here. Okay. So next it will be P1 will be pointing here, P2 will be pointing here, right? And then P1 will be pointing here, P2 will be pointing to the null, right? P2 will be pointing to the null. Next, when P2 is null, so now P2 will point here, right? Head 1, we'll assign head 1 to P2 and P1 will point here, right? Okay. Then again, in the next iteration, P2 will point here. Now, since P1 is null, P1 will point here. Okay. P1, yeah. And then P2, in the next iteration, P2 will point here, P1 will point here, right? And in the next iteration, P2 will point at null and P1 will also point at null. So in this way, this while loop, right? While loop will break because both P1 and P2 are equal, which are pointing to null. Okay. So in this way, our code will work. Okay. So thanks for watching. Let's quickly see the C++ code as well. So here's the C++ code. So we are assigning head 1 and head 2, P1 and P2, right? And then if P1 is not null, we are assigning the next node of P1. Else, if it is null, we are assigning head 2. Same for the case for P2, right? And then finally, if P1 is not null, that means we have found an intersection point, we'll return the data, else we'll return -1. Okay. So thanks for watching. Please don't forget to subscribe to the channel, like the video. Have a happy, healthy, and a great day. Thank you so much.